Inserting market effects and success factors in the cash flow model. Now, we shift to the Model tab, in order to start building the 10-year cash flow. 24. Go to cell G3 and write the following function, equals index, parameters, $K$7, $K$12, G1-4. This function retrieves the nth element out of the range K7, K12. Given that G1-4 determines the first year where we might encounter sales, year 5. Therefore, 5-4 will use the first element on the range K7, K12 for this market penetration percentage. 25. Copy cell G3 to the range G3:L3 to establish market penetration rates for years 5 through 10. 26. On cell G4, we write the following formula that references two parameters, equals G3 times market size times unit price. 27. Copy and paste cell G4 to the range G4:L4 to establish sales for years 5 through 10. 28. On cell G5, write the following formula that conditionally establishes the royalty rate as equals if G4 is less than royalty threshold, Tier 1 royalty, Tier 2 royalty. 29. Copy and paste cell G5 to the range G5:L5 to establish the royalty rate for years 5 through 10. The risk factors on row 6 determine the respective probabilities of success of each one of the stages correspondingly. This information will be used to calculate ENPV and as a parameter in calculating probabilistic NPV. 30. On cell B6, write 100%, as the project is bound to start. 31. On C6, reference cell parameters D15, the probability of being successful by the end of the first year on the scale-up stage, 70%. 32. On D6, reference cell parameters D16, the cumulative probability of being successful by the end of the second year on the clinical trials 1, 28%. 33. On E6, parameters D17, the cumulative probability of being successful by the end of the third year on the clinical trials 2, 17%. 34. On F6, parameters D18, the cumulative probability of being successful by the end of the fourth year on the FDA approval stage, 15%. 35. On cell G6, write a fixed reference to the previous cell, equals $F$6. Copy and paste this formula all the way to the last year for the range G6:L6. Remember that these are the cumulative probabilities at each one of the stages. The total probability of being successful all the way to the launching stage on year 5 is roughly 15%. We will use row 6 as a reference to transform cash flows to expected cash flows, simply by multiplying each annual cash flow times its probability weight. This is the fundamental difference to calculating risk-adjusted NPV. Now, we proceed to create the probabilistic structure that allows the building of probabilistic cash flows and NPVs. They all hinge upon the Bernoulli distribution. 36. On cell B7, write 1, as the project is bound to start. 37. On cell C7, write the following formula, equals B7 times risk Bernoulli, parameters C15. Notice that this Bernoulli distribution depends on the value on B7. If B7 were to be a 0, that is, unsuccessful, then the whole value calculated by this Bernoulli would also become 0. 38. With your cursor on cell C7, click on it Risks Define Distributions button. Since a distribution function has previously been defined on top of this cell, you will see the following dialog. During a simulation, 30% of the iterations on this cell C7 will generate a 0, and on 70% of the cases, a 1, the only two possible values that a Bernoulli could generate. 39. On cell D7, write the following S formula for the probability of success on clinical trials 1, equals C7 times risk Bernoulli, parameters C16. 40. On cell E7, write the following formula for the probability of success on clinical trials 2, equals D7 times risk Bernoulli, parameters C17. 41. On cell F7, write the following formula for the probability of success FDA approval, equals E7 times risk Bernoulli, parameters C18. 42. On cell G7, write the following formula that will either leave a 1 or a 0 contingent on the result of the previous year, equals F7. 43. Copy cell G7 and paste it to the range G7:L7.